Hello and welcome to another one of D's A to D videos. Today we're going to look at completing the square, and I'm going to ask you to find the x-intercepts of this using completing the square. By now you should be able to find the y-intercept pretty easily from something like this. Just a 0 here gives you 0, -3. But for the x-intercept it'll take a little bit more work. So whenever I'm looking at this problem, what I need to do first is I need to set y equal to 0. So the first thing we do is we set y equal to 0. This is how we find the x-intercepts. Always set the opposite equal to 0 to find the intercept. So everything along the x-axis has a y of 0. Well, at this point what we need to do is add the 3 to both sides. And when we add the 3 to both sides, we will end up with an equation that looks like this. So now that we have the 3 here and just the terms from the completing the square part on the right side, what we can do is we can add half of b squared. So half of -5 is -5/2. I'm going to keep it in fraction form. That way when I square it, I get plus 25/4. Well, if I do something to one side of the equation, I have to do the same exact thing to the other side of the equation. So I put a plus 25/4 just to emphasize that these two are the same sign. And the 3 was positive, so they're going to be connected by addition. Note that if I had it on this other side, it would be subtracted over and be a minus 25/4, like we did on the beginner example. But since we're finding x-intercepts, I added the 3 over. Now I'm adding the 25/4. Get a common denominator over 4. The numerator will become a 12 here. So 12 plus 25 will end up giving you 37/4. So this is what you get whenever you combine, like I said, 37/4. Do your common denominator. And on this side, this is a perfect trinomial square that you will always get the square root of the first term will go here, and whatever number you got when you took half of b goes right there. So -5 divided by 2 is -5 divided by 2 right here. Notice there's no x on this term. And then it's all squared. That's what's special about a perfect trinomial square. You can write it as a binomial squared. And if you were to take x minus 5/2 times x minus 5/2, you would get this original expression there. All right? So at this point, you're able to square root both sides. So if I were to square root, so when you square root both sides like that, what ends up happening is you end up getting a plus or minus on the left side. Don't forget the plus and minus. And the squared goes away on the right side. And if you did it correctly, you should have something that looks like this. And basically the square root of 4 is 2. Root 37 is not going to have anything that we can take out, so it stays root 37. And the plus or minus comes down for the ride. Now we have to solve for x, so what we do is we do the opposite on both sides of the minus 5/2. So we end up we do the opposite. We end up adding 5/2 to both sides, and upon doing so, we end up with the following two x values for their x-intercepts. So we're going to have x equals 5/2 plus the root 37/2 and 5/2 minus the root 37/2. Now, these are x-intercepts, so make sure that your x-intercepts has the basic form of some number, comma 0. So whatever this gives you on your calculator, put it in here, comma 0, and then this will be another x-intercept, comma 0. All right? So you can see that they can get a little funky with fractions, but if you just go back and review your fraction rules, you should be okay. That should not be tripping you up on this level of math. If it is, go ahead and solidify your foundation so that it doesn't cause you any problems in the future, because this won't be the end of fractions. All right, I hope I've cleared up any doubts you might have. Practice, practice, practice as always. Check out the advanced completing the square video where I'm going to put a coefficient for a. All right. Thanks for watching. Have a great day.